All right, so we're just taking notes on the phase of matter gas, and we're going to talk very briefly about the gas laws that you need to know for this section. So the first question we have to ask is, what is the volume of a gas? And a gas will take the volume of whatever container is available to it. So you can see in this picture that all the gas particles are filling to take that of the space available by the container. Temperature, I don't want you to think of temperature as how hot or cold a substance is. It acts more like a radar, where it's kind of like a speedometer on how fast the molecules of the substance are going, and it's an average speed. So if my arrow here represents, or let me see if I can get a pen here for a second. All right, so what happens is the molecules of air are hitting the thermometer. And when those molecules of air hit the thermometer, they're transferring their energy to the liquid inside the thermometer. And when that happens, that causes thermal expansion, and that causes the heat to rise. So the more molecules that hit the thermometer, the higher the alcohol inside will rise. If you have very few particles, then there's not a lot of energy being transferred to this alcohol liquid, and so the thermometer will only rise a small amount. So the hotter it is in a substance or in a gas, then the higher up, the more particles will hit the thermometer, and the higher up this liquid will go. Pressure is a force of outward push in the area of walls. If you think of your knowledge of pressure, pressure is when somebody might pressure you to do something. They might be trying to force you to do something. So pressure, I want you to think of, it's a force, and it's usually an outward push on the walls surrounding the object. In this case, if you look at this picture, this is water that was sealed, this was air sealed in a bottle at 14,000 feet. So the air inside of the bottle is equal to the air outside of the bottle. But as the person descends in elevation, so they go from 14,000 feet to 9,000 feet to 1,000 feet, then you will see the bottle starting to cave in on its sides, because when they first sealed this, the air pressure was less, and as they descended the mountain, the air pressure was more, and so that's causing the bottle to start to cave in. The air pressure outside of the bottle is greater than the air pressure inside of the bottle, and that causes this to happen. So how does gas flow? Gas will always flow from an area of high pressure to an area of low pressure. So inside of this tire, you had a area of high pressure. It was filled to the brim with air. It was so full with air, and as soon as this hole was created, all the air gushed out, because outside of the tire is less pressure. So instead of going into the tire when the hole was created, the air came out of the tire, because it went from an area of high pressure to an area of low pressure. So gas always travels from high pressure to low pressure. This is Boyle's law that we learned. We used a marshmallow in a syringe, but what you can notice is that as the volume increases, or vice versa, as I decrease pressure by pulling up on this tube. As I decrease pressure by pulling up, then the volume increases. So the space available gets a lot larger when I decrease the pressure. When I increase the pressure, the gas volume decreases. So now you only have from here to here, where before you had from here to here. So if I decrease pressure, volume increases, and as I increase pressure, the volume decreases. And that's Boyle's law. What's the relationship between temperature and pressure? If temperature increases, then the pressure is going to increase. So if I have a soda can and I leave it in a hot car, the pressure inside of that soda can is going to increase. So if I go to open the soda can, everything's going to gush out of the top because the temperature has caused the pressure inside to increase. Don't get this confused with putting a soda can inside of a freezer. Because when you put a soda can in a freezer, the reason why the can explodes is not because of an increased pressure of the gas inside of the can, but because water takes up more space than as a solid than it does as a liquid. So as the water in the soda will freeze, it causes the ice to expand in the can and causes the can to break. That has nothing to do with gas pressure. So what we're talking here is if I increase the temperature on this soda can, then what's going to happen is it's going to cause an increase in pressure inside of the can, and it's going to cause the can to kind of bulge, so the volume is going to increase. And then once you open it, everything's going to go spurting out. Charles' law is when you have temperature. In order to get this balloon to expand, we have to add hot air. We have to add heat. So we are adding heat to the air inside of the balloon to cause the particles to move very rapidly in all directions. And that will cause the volume of the balloon to get bigger. So Charles' law says that if I increase temperature, if I increase the temperature, so make the temperature go up, so if I increase temperature, then that's going to mean that I increase volume. So a temperature increase means a volume increase. There's going to take up more space inside of this balloon with hot air than with cold air. And those are the sources for the pictures that I used.